Okay, and last but not least, we're now going to look at how the function moves around based on specific values. So we have two different forms. We have standard form, we have vertex form. I've already introduced you to the vertex form, but I haven't really introduced you to all the different pieces yet. So first off, you can see that this A and this A are the same value. And then we have B and C over here. If you recall, the C value is the y-intercept. And then in this case, though, we have our H and our K. H and our K is our vertex here. So we know that the opposite of whatever's in here is our X value, and whatever K is our value out here. So we'll be doing some examples as we go through a few of the problems. And then we're going to learn this stretched vertically, compressed vertically, and all this other stuff. But let's go through a few problems first. So my parent function is just x squared. So based on x squared, how do things move around? Well, if we have another function that says x minus 1 squared, notice that I added a minus 1 to the x inside here. This is going to cause it to shift left or right. Okay, and so the way that it shifts, if you remember for the vertex, that we always took the opposite of this. So that's what happens with the same thing left or right. So when this is a -1, it's actually shifting 1 in the positive direction, which would be 1 right. So the x squared function kind of looks like that. I'm going to actually show you that in a minute. And then with this function, because this point right here, which is your vertex, moved 1 over to the right, it would move there, and now my parabola would be over here. Okay, now it moved to the right because it always moves opposite whatever this number is right here. Okay, so then if we go to the next one, if it's outside the squared, that's going to cause it to shift up or down. If it's positive, it shifts up. If it's negative, it shifts down. So notice this is a +2. So our original equation would look, just like that parabola that I drew up before. That's supposed to be touching the origin. And this one shifts up 2, 1, 2. So then your parabola would just shift up 2. Okay, and then finally, we see that g of x equals x plus 5 quantity squared minus 2. In this case now, I can predict what it's going to do. So the +5 tells me I move to the left 5. Remember, it's always the opposite. The -2 tells me I move down 2. So my function would move there. So it's going to look something like that. So let's go over to Desmos and check that. And so if we see over here, here's our function. So let's take a look at the parent function. So notice this goes through 0, 0, the x squared function, just like we said here. I do want to point out some key features, though, is that when x goes over 1, y goes up 1, right? Right to that point, 1, 1. So we can see that. And then when we're always starting at the vertex. So when x goes over 2, you notice that y goes up 4. There you go. So 2 and 4. When x goes over 3, y goes up 9. Now, why are those numbers seem so significant as I'm talking about them? Because remember, this is a squared function. A quadratic is a squared function, and 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if we were to look at that number up there at 4, that y would be 16 because it's squared. That's what it's doing. Okay, so now let's take a look at some of the functions here. Here's the first example that I went through. Notice that that function moved over just 1. Everything just shifted over to the right 1. When we did the +2, everything shifted up 2. Notice over here when we did +5 minus 2, it shifted -5 and down 2, and so we can see what those functions are doing as it goes through there. So that's how we do the shifts, and the next thing we're going to do is we're going to learn what the a value does to the function. So does it cause it to go up faster, slower? What does it do? That kind of stuff. Does it cause it to go down instead of up when it's negative? That kind of stuff is what we're looking at. Okay, then we have only one more video.